This is the 2011 Queensland Senior External Exam Physics paper. We're looking at paper 1 part B, short response section, and it's question 10, scientific processes. First thing we do is we read the question carefully. Microwave waves of wavelength 3 centimeters pass through two narrow slits as shown below. A receiver attached to an oscilloscope determines a maximum intensity at A with a minimum at B. The next maximum is at C. So we have a signal generator, a 3 centimeter microwave producer. The waves go through slits at Q and P. Then they diffract, and the two diffraction patterns coming from Q and P interfere with one another. And so on the line there, A, B and C, where the receiver is placed, at A is your central maxima, at B is your first minima, and at C is your first maxima. So constructive interference at A and C and destructive interference at B. Part A says, what is the path difference in wavelength between PA and QA? PA and QA are both on the both lead from the slits to the central maximum. PB and QB both go from the slits to the first minima. Part B, what happens to the distance between A and B if the distance between the slits is decreased? B part 2, the microwave wavelength increases, and B part 3, A and B are moved closer to the slits. Okay, we've read the question. Let's go through now and make sure that we identify all of the different pieces of information. So microwaves of wavelength. So we have a 3 centimeter wavelength, pass through narrow slits. Receiver attached to an oscilloscope determines maximum intensity at A. So here's point A, central maxima, and a minimum at B. So B there is your first minima. The next maxima is at C. So there's C there, which is your first maxima. We have a look at part A. What is the path difference in wavelengths between PA and QA? So we need to identify that this is on the central maxima, and in this particular case the path difference is equal to 0. So that particular distance and that particular distance there are the same. A will be perpendicular to the midway point, a line going through PQ, that perpendicular bisector. So A is there on your central maxima. If we look PB and QB, so we look at PB and QB like so, those ones there are going to be on the first minima. Because they're on the first minima, the formula for path difference is half a wavelength. So that there would be, locking in our particular value here of 3, would be 3 over 2, which is 1.5 centimeters. That would be the difference in line from QB and PB. PB will be longer by half a wavelength. That's destructive interference, so in other words, a crest will meet a trough at that particular point B. So there's part A done. Let's have a look at part B. What happens to the distance between A and B if the distance between the slits is decreased? If you decrease the distance between the slits, we can calculate this by looking at the formula sheet. The formula sheet, the first section is on kinematics, which is the first part of the exam. We're doing light questions at the moment, so the light formula are in the second part of the formula sheet, and we have a simple little formula here, delta x equals L lambda on D, like so. That refers to interference. Now the distance between the slits is decreased, so you're looking at this particular distance QP. So if D is decreased, if you decrease this denominator, you're actually going to increase the spread. So as D gets smaller, delta X increases. So distance AB increases. You get greater spread. the microwave wavelength, so that's part 1, let's look at part 2. The microwave wavelength increases, so if we increase lambda, in this particular case you increase the wavelength, you also increase the spread. So the X value will increase as well too. So AB increases, part 2. So X and D are inversely proportional, X and lambda are directly proportional, and if A, B are moved closer to the slits, that happens. What happens if you decrease L? Delta X and L are directly proportional, so if you decrease L, you decrease your spread as well. So AB decrease. Let's go through and just make sure that everything that we've done here in the problem actually makes sense. So delta X, so perhaps I need to put deltas in here just for the examiner so that we know that delta X is the spread, L's is the screen distance, D is the slit separation, and of course lambda is your wavelength, which is equal to 3. So there we go, gone through there and covered off that particular question.